Hello everyone, let's go ahead and take a look at arithmetic sequences. Now let's go ahead and start off with an example here. Here's 36, 31, 26, 21, etc. And if we go ahead and express that using words, we would just say, let's start off with the number 36, and then to get the next term we subtract 5, to get the next term we subtract 5 again, etc., etc. Now, whenever we add or subtract a constant value to find the next term, the sequence is going to be called an arithmetic sequence. Now, before we actually go into the definition, one thing that we want to go ahead and be able to do is we want to be able to, in addition to being able to express in words, is to be able to find the algebraic formula for it. Okay, so the definition is going to help us start to determine that, and then we'll have a formula for which we can actually apply to come up with the formula for this particular sequence, or any other ones which are called arithmetic. Okay, so let's go ahead and take a look at the formal definition here of what an arithmetic sequence is. This is the definition. It says, the sequence u sub n is arithmetic if and only if d is going to be equal to u sub n plus 1 minus u sub n for all n is an element of z plus. Now, what does all that mean? Let's go ahead and translate these parts by parts. It says, this is the sequence u sub n. Go ahead and see this notation. That's what it refers to, the sequence u sub n. This symbol right over here represents if and only if, okay? And it's an equal sign with two arrows on either side. D is going to be called the common difference. Okay, notice what happens is the common difference is going to be a previous term, u sub n plus 1, minus the u sub n term to come up with a common difference. Now, for all n, okay, that's what the upside down A represents, for all, and then the n there. For n is an element of z positive, so what that means is that n is an element of a set of positive integers. Now, what you should notice is that if we want to go ahead and define an arithmetic sequence, we need to show that this is true. Or, which is what this means, if we show that this is true, then we can go ahead and call the sequence arithmetic. Now, once we go ahead and determine that the sequence is arithmetic, then we can go ahead and use a formula, which is u sub n is equal to u sub 1 plus the quantity n minus 1 times it by d, to find the formula for the arithmetic sequence itself. Okay, so let's go ahead and apply this. Now, the idea then is that we need to find out, in order to find this formula, we need to know what u sub 1 is, and we also need to know what d is. Okay, so let's go ahead and take a look back at this example here. So to find the algebraic formula, again, we need to use this here. We need u sub 1 and d. Well, u sub 1, of course, we know it's going to be 36. Now, we need to go ahead and find out what d is. D, which of course is going to be u sub 4 minus u sub 3, or it's going to be u sub 3 minus u sub 2, or it's going to be u sub 2 minus u sub 1. Now, all of those have to come up with exactly the same value. That's why we're going to be calling it a common difference. It could be a difference, but if it's not common, then it's not arithmetic. So we need to make sure that there's a common difference, and sure enough, if we take 21 minus 26, 26 minus 31, 31 minus 36, we're always going to come up with a minus 5. So notice that when I take a look at the sequence up here, notice that it's going from this term minus this term, or this term minus that term, or this term minus that term, which is exactly what this expresses. Okay, so now we have u sub 1, which is 36. We also have d, which is going to be equal to negative 5. I can now go ahead and use my initial statement right here for any arithmetic sequence and say that u sub n is going to be equal to 36, which is u sub 1, plus my n minus 1 times it by negative 5, which of course is going to be the d. So if I distribute the negative 5 and simplify, I come up with u sub n is equal to 41 minus 5n, and that is going to be the sequence generator, or the general term of the sequence that I have up here. So let's kind of go ahead and recap again. Again, if we go ahead and subtract if we can find a common difference between subsequent values or consecutive values of a sequence, then we can go ahead and call that sequence arithmetic. Or if we know that the sequence is arithmetic, then we know that there has to be a common difference. Now, once we have the first element, or u sub 1, and a common difference, then we can actually go ahead and find out what the algebraic formula is, or what is called the sequence generator or general term of the sequence for any particular arithmetic sequence that we have. Now, what is the power of that? Well, here's a hint. If we wanted to go ahead and find use of 100, how would we do that if we didn't have the formula? Right? Then that means that I would have to go 100 terms over here. But now that I have the sequence generator, finding use of 100 should be very straightforward. Okay, so let's go ahead and take a look at some of these examples the next time that we meet, and we'll take a look at any questions that you might have regarding the limitation, as well as the application of the definition and this initial statement to find the algebraic formula for any arithmetic sequence. So see you next time. Bye-bye.